All right, hello. Today we're going to do a little bit more with logs. And so if you want to write yourself a title, this is, let's see, this is Unit 7. It's on logs. And this is day 2 of logs, the second and the last day. All right, so remember from last time, you learned how to change a log to an exponent. So if you had something like log base 2 of 8 equal to 3, remember that meant that 2 to the third power equals that number right there. So 2 to the third equals 8. Or let's say that you had 5 to the negative 2 equals 1/25, because it's 1 over 5 squared. Well, you could write that as a log. Remember that this part here is your base, so it's going to be your base right over here. So it's going to be base 5. So 5, the power goes on the right, and then the 1/25th answer goes right there. Now, if we had our calculators, if we were in class, we could put these things in to confirm, but we can't. So, all right. So a couple of other things I want you to remember that we went over last time. We had 2 different graphs. So we looked at the graph of exponent, an exponential function, and also the graph of a log function, and how they were inverses of each other. So like if we drew y equals 10 to the x, remember it went through 0, 1, came through here like that, all right? And it had a horizontal asymptote of y equals 0. That was my horizontal asymptote. And then if we had a log function, it didn't go through 0, 1, it went through 1, 0, and it came up there, went down there. It had a vertical asymptote right here of x equals 0, our vertical asymptote. Okay, so what I want to talk more about today is our log function, of course, and that log function right there, remember it has a domain. This function only exists to the right of 0, so the domain is everything, all x's greater than 0. The range is all real numbers because it's going down and up forever, so all real numbers, but today we're really going to focus on the domain, okay? And also that asymptote. So I want you to realize that only if I move this graph left or right, then this line would have to change. So if I move this graph to the left, then this line would have to move accordingly. All right. If I move this graph to the right, then this line has to follow. If I move this graph up or down, then this line can just stay right where it is. So up or down does not affect the asymptote, but what does affect it is moving right or left. Okay, so let's practice a few of those things, or look at a few of those things more closely. All right, so for our example here, say we had this, y equals log base 10 of x minus 4. Now, you could see this written as log base 10. You also might see it like this, y equals log and then x minus 4 there. If there is no base right here, then it's assumed to be a base 10, okay? So you don't really have to write it. It's kind of like when we write, we write an x. We know there's a 1 there, but we don't write it. Or when we write like square root of 9. We know this is square root, but we don't write the square root, okay? So you don't really have to write the 10 there, okay? It's just assumed to be a 10 if there's no other number there. All right, so the shift here, this graph, or this function right here, this is moved to the right 4 spaces. So I want you to think about the graph. Move to the right 4. So that means our graph used to go through 1, 0. So now I'm going to move that 4 spaces over. 2, 3, 4, 5. So from here, I was where I was. I moved it 4 spaces over. My asymptote. Well, my asymptote used to be here at 0. But now it's going to be 4 spaces over also. So it's going to be at 1, 2, 3, 4, like right here on this line. All right, so my new asymptote is at x equals 4, and my graph is going to come right up through here and go over. So most importantly, I want to talk about my domain. All right, my domain is everything to the right of 4. So if I looked at the picture, I would say, oh, x is greater than 4. My graph only exists on the x-axis, left and right, between everything after 4, from 4 to infinity, basically. But, you don't always have to look at the picture to tell the domain. What you look at is you can look at this little piece right here. That piece right there has to stay greater than 0, because remember from our last lesson, you can't do a log with any base if there's a 0 here. You can't do it because 10 to a power cannot equal 0 ever. All right, so basically what you do, instead of looking at the graph, you can take this little piece and you can say to yourself, well, x minus 4 has to be greater than 0. And you solve that by adding 4 to both sides. And you say, oh, x is greater than 4. And so that's your domain right there. All right, so let's look at a couple more. So my next example, let's say I have y equals log x plus 3 minus 2. All right, so this thing is moved from your basic log graph. It's moved to the left 3, and it's moved down 2. Okay, so the only thing that moves the asymptote is the leftward motion. All right, because remember the original graph looks like this, and it looks right here. My original graph has my asymptote right there at x equals 0, and if you move left or right, then I have to move my asymptote. Okay, so my new vertical asymptote for this picture is going to be at x equals negative 3, because I'm moving it left 3. My new domain, remember for my domain I do x plus 3 has to stay greater than 0, so I take away 3. So I get x is greater than negative 3, so everything to the right of negative 3. And so now I can kind of draw a little picture. My picture, let's see. My graph used to go through the point 1, 0. So that's going to be moved to the left 3, 1, 2, 3, and down 2. So this piece right here, that dot right there, is going to be basically kind of like a little marker for what I'm going to go through. So let me see if I can erase those other ones. Get rid of that one a little bit at least. All right, so now my asymptote. I'm going to have a new asymptote at negative 3, so right here. All right, and then my graph just comes on up and goes over, and eventually it's going to come up really slowly. Eventually it's going to cross the x-axis, but probably not where we can see it on our graph. But realize that this does have a y-intercept, and eventually it will have an x-intercept. So there is an x-intercept and a y-intercept. And if you needed to find those, you could graph this on Desmos and do that. All right. So why don't we try that? Let's see. I'm going to go to Desmos here. Alright, so I got y equals. Now to get the log, you have to press the functions button and go to miscellaneous, and there is your log right there. And if you want a different type of log, you can do functions and you can choose one right next to it, log base a. So we're going to do log base 10. That's what this one was. And x plus 3. And then parentheses and then minus 2. All right, so if I move that over, there's my my y-intercept right there. And you can see if you move it far over to the right, oh boy, it's really far over. Wow. So if I click on that, up, there it is right there at 97. So if you kind of zoom out here, you can see that function, but and it does keep going down here. Right past 0 there, it keeps going down, but it can't really show you really well. Okay, all right, so let's finish up with our last problem here, the last couple problems. Oopsie. All right, so this last two examples, let's say I have y equals log base 2 of 4x, and I just want to show you how what happens to this right here. So this right here for my domain is that 4x has to be greater than 0, so I divide by 4. I just get x is greater than 0. All right, so that's easy for the domain. All right, now the graph. So let me go back to Desmos and show you this on the graph, like what happens to it. So let's do a regular log function. I'm going to do y equals log base 2 of x. Oopsie. All right, and then I'm going to do another one that is y equals log base 2 of 4x. And I want to, oopsie. Well, anyway, sorry. So what happens when you put a 4 right there is there is basically like a shrinking. I know it looks like it's taller, but what happened, if you look at the x-intercept switched from 1, 0, and it actually switched to 1/4 right here, that 0.25. So what happened is putting a number there next to the x, it basically like shrinks this thing horizontally. Okay, so we don't really have to know that it does that, but you can see how the picture is affected. Okay, whereas if we put a number in front of the problem, what would happen is it would stretch it up, stretch it taller. You see that one? All right, so just so you can see what happens there. So let's go back to here. So really all we have to do for our math space activity is to know that what the domain does. All right, and so our last example is this. Let's say we had y equals log of negative 5x. Right, and I want to know the domain of that. Now that negative inside there, let's go back to the graph and see what that does. When you have log of negative 5x, so let's see, log of x, there's regular log of x, and let me change this one to log of negative 5x. And look what happened. So what happened, the 5 shrunk it in again, and the negative flipped it over. This is a reflection over the y-axis. So I don't really need to know that, but I want you to know what happens to the domain. Basically what's happening is this graph exists to the left of 0 now instead of to the right of 0. All right, and that happens because what I would do if I want to tell you the domain of this thing, is I would take this part, negative 5x has to stay greater than 0, but when I divide both sides by negative 5 to solve this, I get x, then inequality flips around, and I get 0 over here. So there's my domain now. So that means that when I have my xy axis, that the graph is to the left of 0. Instead of over here, that one is to the right of 0. Okay? All right, and that's it. Pretty short lesson for today, and I'll talk to you next time.